Hello, it's Duncan. Here on Team Gilded Rose, we're accelerating. It's another day and another story in our list. The customer has asked that we implement items degrading quicker, so that once an item passes its sell by date, it's reduced in quality by 2 every day, whereas previously it reduces in quality by 1 every day, that is, say, before its sell by date. So this feels like it should be achievable today. Let's see how we do. Let's have a little look at our item class. You may remember that we ended up with a method in here updated by the number of days, and this is where we currently reduce our quality by the number of days we've been updated by, and we here prevent that going below 0. That was yesterday's work. And we have some tests of this functionality, and they're not bad tests really. There is a problem though, and that is that we are testing lists of items in here. We're actually testing this method here, which just maps our update over every item in a list, and that's making this test a bit longer and more complicated than it needs to be. So maybe we should start today just by removing this list, and I think a little multi-edit here will help. So what I plan to do is, let's inline items everywhere. And now we can go and get all these list ofs. And just remove those. And now we should be able to go to the end of the list and remove that. And then this update items wants to be item updated. So now let's take all these update items, take all those, delete those, forward here, and here we're going to say updated by giving it the days. And we very nearly managed to edit it. I just have a spare bracket that I missed. Let's go and fix those up one by one. There we go. Right, so let's run our test. Now, you might argue that we should have a test this update items, but I think we don't really need to test map, and it is being tested by other parts of our code. So let's now go and have a look at the next thing. So our requirement is items degrade faster after their sell by date. So let's go to our test and write a test that shows what we mean by that. So let's borrow a test we've got already. And this one here said items decrease in quality by 1 per day. So let's take that. So this test is items decrease in quality 2 per day after sell by date. Okay, it would have been better had I copied these examples, I think. So let's grab those, put those in there. So now we have a problem. What do we mean by after sell by date? Because this function doesn't know when we're calling it. Now we could take this function and look at the time in here, but that would break our tests. We could only then run them in one place, and passing a clock into item doesn't seem sensible. So what does seem sensible is telling this function when it is we are calling it. So if we did that, then this updated by would have a local date. So let's put that in here, and we could say this would be on. So if we were to say updated by 1 day on October the 29th plus 1 day, then we would expect this to degrade by 2. So that would be 42. Just do 1 for now. Let's give ourselves a chance. Now, all these others, we are going to need to specify this date or give it a default. And I wonder whether we just give it the date of October the 29th all the way through here. So, because that won't change the behavior of these places because that won't be passed its sell by date. Now, I could probably do a better refactor than this, but I'm just going to put all these in and then IntelliJ fix this for me. So we've now got a parameter of local date for our updated by. So refactor that. So that makes all these compile at least. And in here now we know when we're being asked. I don't think it will all compile though, because yes, just here we fail. And I think for now, when we call this, this is being called by production code and not our test. So in order to keep our production code running, or at least compiling for now, let's pass in the items sell by date in there. That won't change the behavior, and we can fix that up in a minute. Okay, so we've got a breaking test, the one we added here, because we haven't updated by 2 days. So let's go and fix that. So in here we can say, how much are we going to update by? There are two ways we can think of this. We can work out how many days were before and after the sell by date, or we can just keep on applying every day. And I think that's my plan. So let's make ourselves a block body to give ourselves some space. And then we say that at the moment, we are reducing this quality by the number of days. Now, that's equivalent to reducing running this code effectively once for every day. Let's just see if that's right. We've got a breaking test, but it's only one breaking test. So let's think of this as, let's have a result, which is this. And then we're going to repeat for the number of days. And we're going to change the result, and the result is going to be, take the result, copy it, subtracting 1 from the results quantity. This is, and then return that. And I think that should be the same result. But this needs to be a var. So let's just see. What we're doing is we're making some space for this calculation to happen. Okay, so that's given the same result in every case, but the failing one that we're still implementing. So let's see how we can make the failing one work. What we could say is that we need to apply a change of 2 after the sell by date. So if we make this 1 our degradation, how much we're degrading by, that can be if on is after sell by date, it's 2, else 1. Let's run that. I thought that should pass, and if we go and look at our test, actually we had the wrong value here. That should have been a 2 subtracted from it. Okay, still don't have a great deal of confidence in this code, so let's add some tests. Add another one that shows that if we update by 0 days, doesn't matter when we update, 0 days shouldn't change the quality. So let's check that passes. Well, that's good. And if we were to go 2 days past our sell by date and update by 2 days, then what will we expect? Well, we'd expect double, we'd expect the quality to go down by 2 twice. So that should be 38. Let's check that. And we're still doing well. But what happens if we straddle sell by date? So if we say we have to update by 2 days, but we're only 1 day apart, then one of our days would be before the sell by date and one after. So we might expect 39. Let's see if that works. And it doesn't. So in this case, we get 38. Let's have a look at our item. And the problem here is that we're asking now this on here compared with this sell by date, but we should be looking on different days to run this code. So what we need to do is we need to count up in days. So we'll also have another var, which is day. And that is going to start at the day that we are now minus the number of days we have minus 1. And we need to make that a long for reasons. Now, instead of asking on, we ask day, whether it's after the sell by date. And then we need to update the day. So we need to go forward a day every time. So we're going to say day equals day plus days 1. And if we get this right, it will pass our tests. Now this has 2 variables and a lot of mutation going on, and we might want to do better than that. But before we do, let's go and wire up the rest of our code. So the thing we didn't wire up here was this on parameter. This on here. And we've cheated. So what we need actually to do is we need to know when we're calling this code in our production code as well. So let us, instead of passing in sell by date there, let's create a parameter for that, which doesn't work for some reason. So I think we're going to add it by hand. Import that. So that should fail to compile. And that's because our stock here takes an update function which takes items and days, but doesn't take our when we are calling it. So we'll call that on as well, and that's our local date. Now that stops this compiling because the signature of this update hasn't got the parameter. And so we now need to pass in, when we call this, a local date, and we have an instant in. But we know that we can say local date of instant now if we have a zone ID, and we have a zone ID. Splendid, run those tests. Now lots and lots of things have failed. More than I expected, to be honest. So let's have a little look. Now in some ways we expect that because we have changed our production code, but in other ways we don't, because we have an implementation of update in our tests that was simpler and isn't the one we have in our item. So just go and find that. Can't remember where we put it. It's here. And you can see this is unused. And so what has actually happened here, I think, is that we did have a reference to this that we were passing in here. But this is now resolved, in fact, to our production version. And so that's broken the places where the test thought that they knew how items would be updated. And that's a bit of a lesson to us, really. It's interesting that we have, by changing a signature, allowed the code to continue compiling, but be broken. So we've been saved from, well, been saved by our test, I suppose. So let's go and solve this problem by changing this to take the parameter that it needs to take. So in order to be compatible, this needs to take a local date, which you can ignore because here we're just decreasing quality. But let's also learn our lesson to call this test update, or simple update items maybe. And we don't want to go and change the name of our production version. Now we can take that, drop that into there. In fact, it has, now it's used, and we'll see how many of our tests now fail. There's one test fails, and that, if we look at it, these are items that are already way out of date. This is the number of days until the sell by date, so past the sell by date. And these stock tests are actually using the production version of the update. We might want to fix that to not use the production version, or we might want to just approve these when they change. For now, I think I'm just going to approve these when they change. So let's run that. Okay, so that's not a bad place to be, but I promised that we would go and have a look at that code in item and see what we can do with it. So here it is. And I kind of think of it as taking this result on a journey through the days, through the first day, through the second day, through the third day. This little bit of code here in the middle is what happens on a day. So we can make a method out of that. And this would be update, and it's update by 1 day. Now, annoyingly, this is A, created a function rather than a method, and B, completely broken. I don't know why that refactor has worked so badly, but it should of course be returning an item here. And using that to update the result in here. If we make that change by hand, then at least it does the same thing as it used to. Now we can do some inlining. Now we can make this our receiver. And now we can make it into a method by removing that. And this horrible mess here. So this is how you update an item by 1 day, and this is how you update items by multiple days. Just rename that to our on. Now, what I think we'll do is we will split this. So at the moment we are updating result and days, but if instead of that we create the days that we want to update the result on, we would be a little more functional, a little less mutatey. So what days are we going to get out of this? Let's see. So this loop is doing 2 things. It's updating the result and it's updating the day. So instead of that, we're going to create the days. And we're going to do that by creating a mutable list of days. We'll call it dates because we've already got days. It's going to have local dates in it. And then we're going to take this loop and we're going to put into our list what we would have called update with. So that's day to start with. So I'm going to say dates.add day, and then we're going to update day. So that should have dates as all the things we were calling update with. Now we can take those dates and we can use them to update our result. And if we're right, that will do the same thing the old code did. Why have we done this? Well, we're trying to remove the mutation, and one way to do that is to prepare the data we're going to work with first and then use that data to update our result. So let's remove the second bit of mutation first. Whenever we see this sort of pattern here, where we're taking a thing and we are pushing it through, updating it by each item in some sort of list, that's a fold. So that code is the equivalent of returning dates fold. The thing we're passing in first is this. That's the first one here, the result. And the thing we're updating with, we're going to update with an item and a date are the two things we're going to get as parameters to our fold. And we are going to say item.update on this date. Shall we see if that is doing the same thing? Comment that out for now so you can look at it and run. Okay, we were right. Now, we could actually just replace this with the reference. So we're folding this through the item update function. I'm not sure that's any clearer for me. So I'm going to go back to the Lambda, but I'm going to remove this old code. So we've used fold to handle the mutation for us, to handle the current item. What about this code up here? Well, I think I've omitted that I rehearsed these, and this took me a long time to reproduce in one expression that looks anything reasonable. So after all my suffering, so you don't have to, I can tell you that this is running from 1 minus the number of days up to 0. I'm going to map that into a function that takes the current day, the one we're actually calling this on, and plus days it, which is the item out of this range. Now what's confusing about this is that this is negative normally. So in fact, whilst it says plus days, it actually is starting negative. I haven't found a better formulation for it, but if it passes the test, it's right. And it does. But as I say, that took me probably 20 minutes of faffing around that I didn't expose you to. Well, we have passed all our tests, and if we have a little review before we go on, we can see that we have changed our updated to fold through the number of dates, and we have added this idea that we degrade more after the sell by date as a private function. We have our stock tests have changed because we are actually using that in one of our tests now. Stock has now had to, its update function needs to know when it's being called. Stock tests has to do the same thing. Updating has to do the same thing. And updating tests, that's the one we just changed and added our functionality to. Now, luckily, because of this change here, we can see that it's actually working in production because this particular approvals test is running our production server effectively. So I think we are done. This is update quality, reduce quality. One warning, go and fix that. And that is our little piece of test code. Let's mark that as unused. And commit. Just before we go, I think it's worth looking at our item class and comparing it with the one that is actually in the Gilded Rose Kata, which is here. You notice they are, this version is mutable, whereas this one is a data class and immutable. But the fundamental difference is that we have stored the sell by date. So we expect the name and the sell by date not to change over time and the quality to change over time. So we persist items with different qualities, but these two stay the same. In contrast, in Gilded Rose, every time you updated your stock, you had to update both the sell-in and the quality. I think this formulation is better, but obviously the original version means that you don't need to know when you're calling the code. You can just update both these properties at the same time, once per day. Well, that's probably been quite a long one. We'll go back to our customer tomorrow and find out what's next in their requirements. I think they maybe had some magical items for us, which would be good because it's the first magical items we've got to play with. If you want to see that episode, then please subscribe to this channel. And if you're enjoying this content, then you'll probably like the book that I wrote with Nat Price called Java to Kotlin, a Refactoring Guidebook. Thank you very much indeed for watching.